Okay, so that was a pretty long warm up, but it's good. You got a taste of what it feels like to wrestle with the problem. Okay, so in the past, like in the previous examples, we have now picked up this strategy of multiplying by the conjugate over the conjugate, and that works well. Remember, when you have a trig function plus or minus 1, or 1 plus or minus a trig function. And if you take a look at this proof, you have 4 opportunities to multiply by the conjugate over conjugate. On the left side alone, you can multiply by either 1 minus cosine over 1 minus cosine. That's the conjugate of the numerator. Or you can multiply by 1 plus cosine over 1 plus cosine, the conjugate of the denominator. Which one would you rather do? Well, it's kind of hard to tell in the beginning, so you could do trial and error. Or you could jump over to the right side, multiply by secant minus 1 over secant minus 1, the conjugate of the numerator, or secant plus 1 over secant plus 1, the conjugate of the denominator. So, wow, with 4 options, which one to choose? Well, a lot of y'all tried this one. I'll just kind of go down that path. You chose to multiply by the conjugate of the denominator on the left side, which there's nothing wrong with that, okay? Now, again, watch your notation. When you multiply by a clever form of 1, make sure there's a division bar there. Lots of people throughout the years just do that. That's like some Chris Angel mind freak stuff. That's like a levitating expression. Whoa. We don't want to do that. Now, you don't need parentheses here around any two-term factors because they're separate factors with their own division bar, okay? But when you multiply them together, if you were to do that, don't go 1 plus cosine of x and then times 1 plus cosine of x, okay? What is wrong with that?
Because that's just 1 plus cosine of x times 1.
Very good. If you write it like that, that's just 1 plus cosine of x, the factor group that you have in parentheses, times the identity element of multiplication, 1, right? And then you do that, and then at the end you add cosine. So don't do that, right? Say what you mean and mean what you say. If you wanted that to be multiplied, you should have parentheses around it, okay? So little notational things. Now, you don't have to do that because you can multiply them up here. When they're the same sign, it's a binomial squared. So you square the first, multiply them together, 1 times cosine is cosine, and double it to get 2 cosine of x. And then you square the last and you get plus cosine squared. Or you can go off to the side and FOIL it, okay? But you do get a middle term of 2 cosine of x. They're the same sign, so they double. Now, in the bottom, your middle terms are going to be opposite signs. So instead of doubling, they do what? Cancel. And you're going to have 1 minus cosine squared. All right? So you do that. And then on the next line, a lot of y'all realize 1 minus cosine squared is sine squared. And again, the Pythagorean identities only work when they're squared. So you can't just in the very beginning call the denominator 1 minus cosine. You can't call it sine or sine squared. It's not squared. All right, so what would we do in the numerator? Well, some of y'all went ahead and changed cosine squared to sine squared, which would be fine. 1 plus 2 cosine of x. Plus, if you want parentheses just to show the substitution, it's 1 minus sine squared. Would those sine squareds divide out now?
No.
Heck no. No, not even. So what are you left with? Well, on the top you have 1 plus 1. You have 2 plus 2 cosine of x minus sine squared of x all over sine squared of x. Okay, so we're not doing anything illegal, but at some point, you look at your target and you're like, bye, target. Right? We're heading further and further away from it, it seems. So now you have the option of either, putting your nose down and just continuing, or going back to the drawing board and saying, that's probably not the right approach. Okay, so it's like if I told you to drive from here to San Antonio, this route that we're on here, you would hop on I-35 and you'd start heading north. That means you're heading towards Austin. and eventually towards Minneapolis, Minnesota, around the Arctic Circle. And then you're going to, in your amphibious vehicle, you're going to come all the way around, and you're going to come up through, Antarctica and South America, and then you're finally going to cross the Mexican border, and you're going to take I-35, and you're going to come up through, Helotes, whatever, and you're going to hit San Antonio. But you got there by going all the way around the globe. That's what this would be, right? You could eventually get there. It's just going to take a little longer. So maybe by the time you get to Austin, you're like, this doesn't smell like San Antonio or look like San Antonio. And so you turn your car around and you drive back the other way. Yeah. San Antonio, especially on the Riverwalk, smells like fajitas, Mexican food. Okay. Austin smells like like parts of Colorado. Yeah. What's that? Yeah. Mary Jane.
Trying to say dank. It smells dank.
Yeah, there you go. There you go. All right. So you could then try multiplying by other conjugates. There's 3 more opportunities. And you're going to see that you're going to kind of get to the same place. We're like, So even though it's a strategy, conjugate over conjugate, it's not something that you necessarily do every time. So what else could we do? Well, perception. We have cosines and secants. How are cosine and secants related? They are reciprocals of each other. So if we draw a line down the middle, they look equally complicated in terms of their setup, but secants may be a little grosser because we're not used to them. We like sine and cosine. So that strategy of putting everything in terms of sine and cosine could work, especially when I know I can write secant in terms of cosine. So let's do that. Now, when we do this, we have to think of the right side as being like a matrix with 4 positions. Top left, top right, bottom left, bottom right. When you replace the secant in the top left, that top left position becomes 1 over cosine. The top right position is still plus 1. All over the bottom left position, which was secant, is now 1 over cosine, and the bottom right is still minus 1, okay? That's how you have to do it. You can't just bring the secant from the top to the bottom because they're not factors, they're terms. So remember, with terms, you always have to be a lot more careful, not just a little bit more careful. Now, state change flip doesn't work here because your denominator is 2 terms. So you have 2 options. You can either get a common denominator in the denominator, call 1 cosine over cosine so that you get a single fraction, and then state change flip. Oh, that's a lot of work. I'm exhausted just talking about it. Or you can adopt the new way that I mentioned in the beginning of the year, which is lick 'em over lick 'em, right? Lick 'em over lick 'em. It works every time. All you do is you check out your miniature denominators, and in this case it's cosine. So the LCM of your miniature denominators is cosine. So you extend the main division bar out, and you multiply the top by a cosine and the bottom by a cosine. What is cosine bless you divided by cosine bless you? 1. Okay? Now, because you have layers, remember I talked at the beginning of the year about having upstairs, downstairs? Okay, the main division bar is the subfloor between the upstairs and downstairs apartment. In the upstairs apartment, though, we have bunk beds. See that? So if you want to put cosine of x over 1 so that now he's on a bunk bed, what you're doing is you're distributing this to both terms, okay, upstairs. So let's take care of the upstairs. When you distribute, what is 1 over cosine times cosine over 1? The cosines divide out and you're left with 1. Good. And now you distribute plus, what's 1 times cosine? Cosine. And when you do that, your complex fraction should be eradicated. No more bunk beds. Still got upstairs, downstairs, but no more bunk beds. And now we kind of go downstairs, right? There we go. Here are the stairs. Now we're downstairs, and we do the same thing. You can put that over 1 if you want to. You distribute cosine of x times 1 over cosine of x is 1, right? The cosines divide out. And then minus, what's 1 times cosine? Cosine, okay? And now you take a look over at the left and you're like, hey, holy moly smokers. HMS, holy moly smokers. Okay. Holy moly vapors, maybe. That y'all can relate to that. Holy moly vapors. No, I like smokers. It combines holy moly and holy smokes all in one. Holy moly smokers. G.E. Willikers. Golly, G. Willikers. That's kind of extra flair. GGW. Hey, Gigi, that's almost JoJo. Yeah. Golly G. Willikers. Those are great. Holy moly smokers, golly G. Willikers. I love those. You could also do the same thing on the left side, call the cosines 1 over secants. And in 2 lines, you have your proof. So, what do we learn from that one?
Conjugate doesn't always work.
The conjugate over the conjugate doesn't always work. You're welcome to try it, but it doesn't always work. So sometimes you need to try a different method and being very perceptive, knowing your trig identities, right? Knowing that you can write secant in terms of cosine, knowing that you can write sine in terms of cosecant, knowing that you can write tangent squared in terms of secant squared, stuff like that. That's the level that you need to have those identities memorized. All right, we're on a regular schedule here today, right? So we got till 41. All right, so we could just write our own little kernel of wisdom here. Conjugate over the conjugate doesn't. Good morning.
Ms. Coffison, do you have any yarn for her?
Oh, someone from her class came by yesterday
Yes,
and picked it up. Did she not get it?
I don't think
She sent you this morning to get it?
Yeah, she said to go to 903.
Oh, okay. Well, tell her that somebody came by yesterday afternoon and I sent them with a bag full of yarn.
Okay.
So if they didn't bring them back to her, maybe they're home right now crocheting something. I don't know.
Alright.
Yeah, but tell her I already sent it. Thank you.
Alright.
Okay? All right.
Take care, man.
All right, you too. Nice guy. All right, the conjugate over the conjugate doesn't always work. You're welcome to try it, but it doesn't always work. Okay? And by work, I mean work in a relatively short amount of time, because we could have stood our ground and continued on and ended up with it working. And maybe, someday if you want to go back and revisit that, we could do that if you want. But right now we need to move ahead. All right, example 8. Guess what the instructions are. No, not solve, right? Solve would mean conditional equation. Prove, right? We don't draw lines down the equal sign when we solve, but we do when we prove. Y'all want to try this one on your own, or you want to walk through it together? Okay, good. On your own. Is that what you said? I have very selective hearing, my wife says. Did you get it? Yeah, try it on your own. Chew on it on your own a little bit, and then when you get stuck, I'll come over and help you chew. Chew, chew, chugga, 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 chugga. Ooh. Stacy Coase, what in the world did you do? You just freaking knocked that one out of the park. Grand slam, home run, 2 outs, bottom of the 9th, down by 3 bases loaded, full count, grand slam, World Series final game 7. Asteroid heading towards Earth, the absolute last thing. Whoa, no, we want to play another season. We better send Bruce Willis up. Ben Affleck, yeah.
Oh, yeah.
Yeah, he was the son-in-law-ish. Armageddon. Yeah, it was a good movie.
Who's the guy that goes crazy and has to tie him up? I remember his back.
This one here, you can use a lot of the techniques that we've already been talking about. Like maybe even the very first example we did. Uh-huh. That's what Stacy did. Waiting for a good pitch. There it is. Smash it. Well, chewing on that, I heard something interesting this morning. Kyler Murray is expected to go number one, but if he doesn't, if he goes to the Oakland Raiders, just hypothetically, if he goes to the Oakland Raiders, he could play in the same stadium for the Oakland A's and the Oakland Raiders because they share a stadium. So there would be a point like during the football game where he's about to throw a pass and he's literally standing where he could be during a baseball game throwing a baseball. That's pretty cool. That's pretty cool. So it's what will Cliff Kingsbury, what will he do? What will he do? He has the first pick in the draft tonight, starting at, what is it, 7 o'clock Central, 8 Eastern? Yep, tonight. Our very own Cliff Kingsbury from New Braunfels, Texas, has the first pick in tonight's NFL draft. And he was quoted as saying a couple of years ago when he was still at Tech that he would take Kyler Murray first if he could. But we'll see. We'll see. Tonight is the draft, yeah. 7 o'clock. Oh, okay. I'll have to tell you at the end of class. Yeah. ABC is doing a broadcast. ESPN is doing a broadcast. So there's a lot of different ways you could take in the draft tonight. Did you get it? Did you get it? Did you get it? Okay, let me see. Let me see.
I don't even know how to start. I didn't get it. How do I start help?
Oh, you went with the little box at the end? That's good. I like that. Orale. Boom! You got it.
Yeah, I didn't want to hurt you with your ring.
You don't want to hurt me with your ring?
Yeah, because you went like that. And I was
Oh, yeah, I was wondering, you kind of gave a little bit of a, okay, that must be some ring, like superpower. That is absolutely correct. Well done. Beautiful, beautiful. Anyone else getting it? Yeah, y'all are getting it. Awesome, awesome. Oh, yep, just make sure you have parentheses around there, right? Because if not, it's technically that times one, but yes. Yes.
When I factor, why doesn't, how I asked you earlier, when I went to here, why is there not a 2 out front? And
Okay, because if there were parentheses here, notice if you check by distributing, sine squared times 1 is sine squared, minus what's sine squared times sine squared? The sine to the 4th. Because remember, that's an exponent. That's the same as sine times sine times sine times sine. That ends up being sine to the 4th. So you're dealing with exponents, not coefficients. Okay?
and I got all the way to right over there. I
Okay.
think. Unless I'm,
And that's good. How did you end up with the sine in the bottom? Ah. First of all, cosine is not 1 over sine.
yeah.
Yeah, cosine is 1 over secant. So what if you just left that as cosine all the way off to the side? Then you're going to have a cosine here times cosine squared, which is what?
Cosine.
Yeah, there you go. And that's it. Did you get it? La, la, la. Yeah, heck yeah. Kaboom. Nice. Y'all are getting it. Y'all are getting it. Oh, I was looking at the wrong one. Sorry. I need to zoom in. My eyesight's bad and it's dark. And you're using kind of a light color. Yeah. Yeah, you just need to sign off. Yeah. It's funny. A lot of people don't like fist bumps. Yeah. What? You afraid you're gonna hurt me?
No, I just don't.
You think my hands are dirty? Or you think it promotes violence?
No.
What would you rather do? A high five?
I just don't like.
You don't like touching.
Yeah.
Okay, I got it. Okay, air high five. Okay. Well, that's why we go to fist bumps, right? Because used to be like handshakes where you like take it in like the whole sweaty palm thing. So now fist bumps are just like a real quick tap, but it's still touching. Okay, good. High five. We're on the same page now. Okay, how'd you do? Oh, you factored it like a difference of squares. That's awesome. See, and that's an option. I like that. It's starting to get bad. Okay. So I like that you did that. That's awesome because it is a difference of squares. But what's the first, and that could work potentially sometimes, but what's the first rule of factoring? Look for a common factor. And there's a common factor of sine squared. So you factor out the sine squared. Yeah. That's awesome. I'm glad I looked over there. All right, let's go through this one. Most people started on the right because there looked like there was more stuff. Sine squared minus sine to the fourth, interestingly enough, is a difference of squares, right? So it could be that you want to factor that as sine of x minus sine squared of x times sine of x plus sine squared of x. Okay? That's not something that even came on my register because I kind of know how to do it. So sometimes I get kind of caught in this narrow-minded vision of things without exploring other options. So that could totally be a possibility. Now, when you do that, if you notice your target on the left, you do want to end up with the sine squared. And you have some sine squareds in here. So would you then change these sine squareds to 1 minus cosine squareds? Possibly, okay? Possibly. But in this case, just like conjugate over conjugate doesn't always work, difference of squares factors doesn't always work. So let's see what we could do. Notice if we do decide to start on the right-hand side, the left-hand side has a factor of sine squared. You see that? Do I have a factor of sine squared that is common in both of those? Yes. So then that is going to inform your decision maybe to factor out a common factor of sine squared. Boom. And now all of a sudden this is matching this. Okay? Now, when you factor out, remember you're dividing out. So sine squared divided by sine squared is 1. Minus sine to the fourth divided by sine squared still leaves the sine squared. And then we have times cosine. All right, so I'm not going to mess with my sine squared factor anymore. It's done. So what else do I have to accomplish here? Well, I need 3 factors of cosine. I currently have 1 factor of cosine. So I need to get rid of 1 minus sine squared and in the process pick up a cosine squared. Well, hey. That is totally doable, right? Because 1 minus sine squared is cosine squared by the Papa PID. So we write that step, and now we got cosine squared times cosine. So we get cosine cubed of x, and ain't no thing. Ain't no thing. Ain't no thing. Golly gee willikers. I like that a lot. Holy moly smokers. Oh, okay. Did anyone start on the left side? Any sinister people in here? Left-handed, left-sided? Let's take a look at what the left side would do. If we did start on the left, the right side now is our target. And you'd be like, okay, I have a cosine cubed. I need a cosine only. That's the only cosine I need. So here's what I'll do. I'll keep my sine squared. I'm not sure what that's going to do for me. But I'm going to split up cosine cubed. I'm going to call it cosine squared times cosine. And now you're like, I got my cosine locked in. I'm not going to mess with that, okay? And now you're like, okay, what's left? I need to get sine squared minus sine to the fourth. So this cosine squared, he's got to go. I don't need any more cosines. I need to pick up a few more sines. So I'm going to now replace cosine squared with 1 minus sine squared. And now, instead of factoring, I will distribute the sine squared minus sine to the fourth times cosine of x. And you get the same thing. And if you notice, what I did on the left side is kind of this in reverse. Okay? So again, it depends on how you see it. If factoring is a little more obvious to you, it works. If expanding is a little more obvious to you, it also works. Okay, cool. Y'all are getting the hang of it. Y'all are getting the swing of things. Example 9. Do we have time for it? We have like 3 minutes. So, in the final 3 minutes, what was the other joke? Okay, the other joke was from 1984. It was from St. Louis, Austin. Yes, that's right.
Okay.
Wow, way to go, Stacy. Stacy's on a roll. So anyway, real quickly, because we don't have a lot of time, he told this joke during his homily, and he said this new priest was assigned to this small little country church, and he wanted to make a good impression on the congregation. So he walked into the church, and he noticed the walls were all dilapidated, and everything could use like a fresh coat of paint. So the church was poor, and he was poor, so he went to the local hardware store because we didn't have Home Depots back then, and he had enough money for 1 gallon of latex paint. So that's all he could afford. So he got some red paint, and he realized it wasn't going to be enough for the walls. So he thinned it with water and started painting. And of course, when he was done, it looked horrible because he had to stretch the paint too far. He thinned it too much, and it was really, really bad. So he scrounged up some more money. He prayed on it, and he found some more money, enough for another gallon of paint. But again, he had to come back, and he had to thin it with water to make it cover all the walls. And it looked a little better, but it still looked like crap. Okay? And so he prayed on it and prayed on it and prayed on it, and all of a sudden, a big voice from heaven came down and said, repaint and sin no more. And he's like, thank you. And that was the end of the joke. Repaint and sin no more.
Like saying repent and sin no more.
Repaint and sin no more. Repaint and sin no more. Instead of repent and sin no more. Anyway, you had to be there, as they say. 1984. Father, whoever, I forgot his name, whatever he was. Wozniak, maybe. Okay, tomorrow we will hopefully finish. We will finish tomorrow. So make sure you're working on Das worksheet, okay? Das worksheet. And have, when we finish 6.4. So we still got a ways to go.